If you are considering or have chosen to study the Bachelor in Technical Computer Science at the University of Twente, it is important to be aware of a particular organization of the curriculum, the so-called Twente Educational Model, or TOM. We are using the Dutch acronym, which is why we never talk about TEM. In this video, I will explain the setup and rationale behind it. Why TOM? Any academic bachelor in computer science, all around the world, pretty much shares the same topics, even though the balance may differ from place to place. After all, if you have a bachelor degree, society expects a certain skill set on a certain minimal level. So the content of our program is, to some degree, prescribed and fixed. What is not fixed is how we organize it. Once upon a time, our computer science program was like any other in the world. We had courses on math, programming, design, architecture, networks, security, data, interaction, as well as a minor and final projects. All were 5 or 10 EC, and they were distributed evenly through the 3 years of the bachelor. Students could study them in order if they wanted to be finished in 3 years. If they missed a course, they could always do it later at the cost of some study delay. Guess what? About 5% of students did finish in 3 years, and many students decided they could always do the math parts later. We had students who finished the entire program except for some first and second year math courses, and who eventually left the university without diploma, because without the context of the rest of the program, just finishing those pesky math courses, which they didn't like in the first place, was just too hard. More importantly, from a content point of view, there was little coherence in the program. This was partially due to the lack of coordination between the different courses. Neither the students, nor indeed the teachers, made explicit connections between different topics, because they were too much distributed over the years. Partially, this was again due to the fact that even though the nominal program dictated some order, students back then were just as creative as you are, and many preferred their own choices. Tom changed all this. We grouped courses with related topics together in a module and added integrating projects so that you would directly apply what you learned. One module is 15 credits and takes 1 quarter. Very importantly, we made the modules atomic, so that it is not allowed to do one part of it this year and the other the next. You have to learn everything in context and are asked to master the content of a single module in one go, hold it together in your head during 1 quarter. Teachers of the different topics know what else you are learning at the same time, and in doing the project you can draw upon the fresh insights that you have recently gained within the same module. As an example, let's take Module 2, called Software Systems. This consists of a design part where you learn about requirements modeling, sequence diagrams, state charts, software architecture, and more. There is a test and a small project which ends midway the module. At the same time, and more intensively afterwards, you learn object-oriented programming in the language called Java. Again, there is a test where you show your understanding of the concepts and theory. Finally, the module has an integrating project in which you design and program a game and have your implementation play against that of your fellow students. All these 4 components get a grade, and for all of them you have a resit or repair opportunity if you don't manage to pass the first time around. Now, the atomic nature of the module implies the following. If you do not meet the pass criteria for one of the 4 parts, then you fail the entire module. Next year around, none of your results will be valid anymore. You have to redo the entire module. Exceptions are only made for students with special circumstances. However, Tom is there precisely to help you forward. If you have the required affinity and skills and apply them consistently, you will pass the module. Guess what? The number of students who finish in 3 years in Tom is 30%. Still not great, but an enormous improvement. Of course, if you do fail a module, you have to repeat it completely the next year, and it will then not be possible to also follow the module of the year you are actually in. So study delays certainly still occur. But since we also offer the final 2 modules twice a year, that's not shown in this animation, the average study duration is much improved. However, this is not quite the end of the story. What I just described was the original Tom, which in retrospect we now call Tom 1.0. The world is turning, evolution has occurred, and we have made some modifications. What changed and why? Well, the integration of the modules was never perfect, and moreover, the reasons why big atomic units seemed such a great idea in the first place started to be forgotten. Mathematics is taught in its own rhythm and cannot always be connected to the computer science core of a module. The disadvantages and apparent illogic of having to redo topics that you already proved to have mastered loomed larger and larger. These factors combined in the decision to split off the math parts of the modules. In Tom 2.0, these are separate study units, no longer integrated with the computer science core. With respect to that core, however, we strongly believe that the all-or-nothing nature of the integrated modules was always a large part of what made Tom work. So our decision has been, let's exempt math, but by all means, let's hold the rest of the modules together. That is where we are now. And that is why Tom.